All right, guys, one thing that we left out of chapter 2 was 2.7 right here. So we're going to deal with that real quick before we get into chapter 3. And it's okay that we kind of left it as an afterthought. We were doing a lot of graphing, finding vertical and horizontal asymptotes, things like that. And you can see this one's way different. First thing we're going to do is clear the fractions. So if I have 2, 5, and 10, the least common multiple, right? So in other words, what would the common denominator would be? It would be 10. Okay, so what we're going to do now is distribute that the whole way through here. So half of 10 is 5. We want 2/5 of 10. So 10 divided by 5 is 2. So it's going to be 4. And we end up with 10 cancels this 10 out. So it's x. So look at that. X equals 9. And we're kind of done with it. So what we do is go back in and check it. We're not going to do that until we get to some healthier quadratics here. All right, next one we have going on. What's the common denominator, right? This would be over 1, this would be over 1. So we don't really need any of those things. We just see that there's an x in the denominator, so I'm going to multiply by x for this whole entire thing. So what that happens is now I got x squared plus 3 equals 4x. I'm like, oh no. Okay, suerte. What are we going to do? I have a quadratic and a linear term. So let's get that over here. And find out if there are any factors of 3 that add up to 4. Well, it turns out x minus 3 and x minus 1 will give me 4. So I get solutions of 3 and 1. Then we have to plug them in. So if I get 3, does that work? So 3 plus 3 over 3, does that equal 4? And 1 plus 3 over 1, does that equal 4? Okay, so I said once we get to quadratics, we're going to have to check a little bit. So I get 4 equals 4 here and 4 equals 4 there. So they're both good solutions. So we'll keep them. I like good solutions. Why? Because they're good. That's why. Okay. Next one we have going on here. What in the world is this mess? Okay. We'd like to get rid of some things, but so common denominator, I have 5x and 5x. So there's a potential I could put these together and then multiply eventually. But, you know, to me, I'm like, if we're going to clear fractions, let's just do it from the beginning. But by all means, if you see a partial, like these two terms here, then go ahead and do that. You know, in this sense, it might be nice because then I could cross multiply. All right, I'll just shut up and do it this way. But just don't forget that you have other ways you can do this. So the x cancels out the x, so I get 5 equals the 5x cancels out the 5x. I got 1 minus, I get 5x cancels out 5x. All right, and it's minus this whole term. So I'm going to use x minus 1 in parentheses here just to be safe. So I get 5 equals 1 minus x plus 1 as I distribute. So I get 5 equals 2 minus x. I'm going to subtract the 2 to get 3. So x is supposed to be negative 3. Okay, that's potential, so we can plug it in and make sure that that works. 1 over negative 3, 1 over negative 15, and minus, let's go with negative 3 minus 1 over top of negative 15. So here, let's go ahead and combine our like terms. All right, so what do we got here? I got negative 4. So we get 1, so we get 3 over negative 15. Is that negative 1/3? What did I make it 3 for? Right, because this is double negative. So let's make it 5, and that is 1/3. So it's a good bingo. We'll keep it. All right, so you see how easy it is to get those things mixed up with some of our signs. So just be careful with that, especially as we sub some things back in. Oh my gosh, look at this. I don't even know. Let's just scribble this one out and pretend like we never saw it. Okay, never mind. We can't do, seriously, erase it. You can't do that. All right, x minus 3, x minus 1. Signs are the same, both negative. Goodness gracious, we just did this problem a couple seconds ago, right? We're going to do that. Okay, here we go. What's my common denominator? X minus 1 and x minus 3. Woo, there we go. Distribute. So x minus 1 cancels. So I need 2x times what's left over? X minus 3 plus 1 times x minus 3 cancels this time. So I need x minus 1. There it goes. And on this side, they're both going to cancel out. So it's plain old 2. So what a relief it is that something worked out relatively nicely. Oh no, we have a quadratic. All right. 2x squared minus, oh my gosh. It is, It's not even Monday, but I'm having a case of the Mondays. All right, so just check my work here as we go, guys. All right, so minus 6x plus 1x minus 1 equals 2. All right, 2x squared minus 5x. Let's move this over. See what I mean? Do you see what I mean? Minus 2, minus 3. I don't even think I can publish this to the true web. This might have to be hidden. I don't know. Either way. Right. But you know what I was doing? I was thinking of what the answer was, and I just wrote it down. Okay? It's not like I don't know what I'm doing. I just messed it up. Okay. Here we go. Are there factors of 6 that subtract to give you 5? There sure are. Okay, so you can factor by grouping. I have a bunch of prime numbers, so I'm just going to go ahead and put them in the right place. So I want to make sure I have negative 6, right? This is going to be negative 6. This must be plus 1 equals 0. All right, so potential solutions here. X equals negative 1/2 and positive 3. And these are the things we want to plug in way up here in for all these x's. Okay, so we're going to try those out. 1/2 and then also negative 1/2 and 3 just to see if they're going to work. All right. Next one. Now, this one's really close to doing a cross multiply, but I have this minus 1 in here. It just messes everything up, and it's going to cause quite an issue as we go to solve it. You can tell by my smile that I'm kind of happy about that. X plus 3, x plus 2, so that makes up my common denominator. So I have x minus 2, and then we're going to cross out the x plus 3, right? So I get x plus 2. Okay, so that's just the first term. And then I got minus 1 times what? The whole thing. All right, now I'm just ready to cry now. This is just terrible. X plus 2 cancels, so I need 3 times x plus 3. Look at this thing. Wow. This reminds me of 2020 when everything was all messed up. All right, so the first one, these are, this can be difference of squares, right? Because you get positive, I have conjugates. So x squared minus 4 minus 1 times. So notice I'm going to keep my parentheses as we do this FOIL. X squared, 2x and 3x, that's 5x plus 6. And it equals 3x plus 9. All right, let's finish this thing up. X squared minus 4 minus x squared. Well, that's kind of nice. Minus 5x minus 6. 3x plus 9. All right, x squared minus x squared. There it goes. All right, so I get negative 5x. I get minus 10. We're getting somewhere. 3x plus 9. All right, let's see what happens. Let's go and let's see, subtract 3x. Yeah, subtract 3x. Add 10, add 10. All right, so we got 8x adds negative equals 19. Well, that's a mess. And divide by negative 8. All right, so we'll say 19/8, and it's negative. All right, so again, we'd be plugging it back in. I just want to make sure that we have the idea of what to multiply at this point, because checking it, like Santa Claus, checking it twice. All right, this one is x and x plus 2. So if I just multiply by x and x plus 2, that'll make up and fix all of that stuff. I'm going to leave it separated as I multiply, so I know that this one goes away. So I have x minus 3 times x plus 2. That makes up my very first term, plus 3. X plus 2 is going to cancel, so it's just x. So that's a little bit nicer. Still get a quadratic from back in the first term. Plus, now the whole thing cancels out. So 6 equals 0 times this whole mess would be just 0. So this isn't the worst problem we'll ever do. Probably ends up being a quadratic. We need a quadratic formula or something for. Now that I said that, man. X squared, we got 2, so minus x minus 6 plus 3x plus 6 equals 0. All right, minus 6 plus 6. Let's get rid of those. I get x squared 1, negative 1 plus 3 is plus 2x equals 0. All right. All right, so it's not the worst thing in the world, but it does create some issues. This has the GCF, guys, x and x plus 2. So that means x could be 0 or x could be negative 2. All right, so those are our potential solutions. And based on the original problem, right, we had here it is. I'll stop saying now. We were over x. So that means this 0 is definitely not an answer. So I'm not even going to check that. So I'll give you that one. All right, guys. A couple things in here you guys still have to go back and check to make sure that it does work, that it gives you a true equation. But if you have plain old x and you get 0 in the answer potential, then we're going to get rid of that one. All right, I'm going to shut up now. All right, thanks for dealing with it, and have a great day.